Hello. So in this video, I am going to tell you how you can solve this particular question, question number 10 on superposition theorem from the book Engineering Circuit Analysis by Hayat Kamarli and Darwin. So what this question is? The question says that using the superposition theorem, we need to determine the value of Vx in the circuit. Vx is this, the voltage across 1 ohm resistor, right? So to do this question using the superposition theorem, we know that when we apply the superposition theorem, so we just need to determine the effect or the voltage across 1 ohm due to this separately, due to 2 ohm separately, and due to this 4 volt separately. Means we are going to have 3 cases. First, in the first case, let me draw this. In the first case, we are going to consider only this 4 volt, right? And we are going to deactivate this 2 ohm and 5 and this 4 volt sources, right? So over here, and once we get this circuit, we need to solve using any theorem, right? And over here I put Vx1, just which indicate that over here this Vx, it is a Vx1 is the voltage across 1 ohm due to this voltage source, right? Similarly, we can have another case. In the another case, what we can do, we will consider only this one, right? So we will have this voltage source will be deactivated, means we are going to replace it with short circuit. We are going to consider this voltage, this current source 2 ampere, this resistance as it is, and this voltage will be short circuited. This voltage will be short circuited, right? So I short circuited. So it is 4 volt. Sorry, it is 2 ohm, 1 ohm, 3 ohm, and let the voltage over here, let it be Vx2. So Vx2 is the voltage across 1 ohm due to 2 ampere current source, right? Now similarly, we can have third circuit where in which we will consider only this, right? Only this 4 volt, and this current source and this voltage source will be deactivated, right? So let me draw that one as well. So over here again, we will have 3 resistors. This voltage will be deactivated, right? Second, we have the current source, so it is also going to be deactivated. So we have this open circuit, then we have a resistor, right? Then we have a resistor, and then we have this voltage source, which is 4 volt, and it is 3 ohm, 1 ohm, 2 ohm, 5 ohm, and let this voltage be Vx3, right? So in this way, we have the 3 circuits and for 3 different independent voltage and current sources, and for that we have 3 voltages, Vx1, Vx2, and Vx3, right? And as per the superposition theorem, this Vx, as per the superposition theorem, this Vx will be equal to Vx1 plus Vx2 plus Vx3, right? So means now our question, we need to determine the value of this Vx1, Vx2, and Vx3, right? So to solve this particular problem, what we can do, we can apply any theorem. So let me apply the nodal analysis. So if I apply the nodal analysis at this point, let this be the node A. So I will have the nodal equation as V upon 5 for this, plus for this I will get V by 2, plus for this current I will get V minus 4 upon 3 plus 1, because there are two resistors, 3 and 1 ohm, 0, right? So this will be the nodal analysis, nodal equation. This will be VA, because I consider node as A and let the potential at node A be VA. Similarly, for this second one, for this one, again, what we can do, I can, like, since this 5 ohm and this 2 ohm, they are in parallel to each other. So what I can do, I can redraw this circuit like this. So it is 1 ohm, this is 3 ohm, and this is 2 ampere, and this is plus minus Vx2. And this 5 and 2 ohm, since they are in parallel, so simply I can determine the equivalent resistance. So equivalent resistance, it will be 2 into 5 upon 2 plus 5. So it will be 10 by 7 ohm. So simply I will put 10 by 7 ohm. Right? Now, for this I can write a nodal equation considering this as A node. So it will be VA by 3 for this current. For this current, it will be minus 2, and for this current, it will be VA upon resistance is 1 plus 10 by 7 equal to 0. Right? And similarly, for the third circuit, for this third circuit, again, we can write a nodal equation considering, let me consider this as a node VA. So it will be, for this, it will be VA upon 3 plus 1. For this, it will be VA upon 5. And for this, it will be VA minus 4 upon 2. Right? Now, if let me solve these nodal equations one by one. So for this case, I will take VA, or this 3 plus 1, it will become 4. So let me write VA upon 5 plus VA upon 2 plus VA minus 4 upon 4 equal to 0. VA common, so 1 upon 5 plus 1 upon 2 plus 1 upon 4 equals to 4 upon 4. Right? So VA, and this is LCM will be 20. So 4 plus 10 plus 5. So simple mathematics we need to do. So VA, it will be 20 upon 19. 20 upon 19 volt. Right? Similarly, for the second case, for this case, it is, again, it is VA by 3 minus 2 plus VA, and in the denominator, this one, it will be 17 by 7. Right? So I can write this as VA upon 3 minus 2, I can take it on the right side. So it will be 7 upon 17 VA equals to 2. Solving this, it is LCM will be 51, 17 VA plus 21 VA equals to 2. So it will be 38 VA upon 51 equals to 2. So VA is equals to this 2 and this 19. So VA is equals to 51 upon 19 volt. Right? And now for the third equation. For the third one, it is 0. So again, this 3 plus 1, it will be 4. So VA upon 4 plus VA upon 5 plus VA upon 2 equals to 4 by 2. Right? Now this is exactly this one. Right? So already we solve it as VA 19 by 20. So we do not need to solve it again. So directly I will write over there. Right? So it will be VA 19 by 20 equals to 2. So VA, it will be 40 by 19 volt, right? So once we get VA, so what I need to determine? I need to determine Vx3. To determine this Vx3, what I need to determine? I need to determine this current, right? So this current will be VA, this current I is equals to VA upon 3 plus 1, right? Now VA is this 40 by 19. So 40 by 19 upon 4. So we will get 40 upon 19. So 10 by 19 ampere, right? So this is the current. Now as per this current, if I want to determine the voltage, now as per this current, plus will be on this side and minus will be on the arrowhead, and this polarity, it is in opposite direction to the given polarity, right? So it means that Vx3, it will be equals to minus of I into 1. Vx3 will be equals to minus of I into resistance, which is 1, right? The resistance value is 1 and I is this 10 by 19. So substituting this value, we will get Vx3 as 10 by minus 10 by 19. Now for the second case, again for the second case over here, we have determined for this one, we have determined VA, right? VA is coming out as this 51 by 19. So now first we need to determine this current. This current I, it will be equals to, I is equals to VA upon 1 plus 10 by 7, right? So it is 7 VA upon 17, right? Now substituting the value of VA, VA is 51 by 19, right? So substituting the value, we get 21 by 19 ampere. So I is this. Now this is I. So our Vx2 over here, plus is over here, minus is over here. So Vx2, it will be I into R, which is 1. So it means Vx2 is equals to I, which is, and I is 21 by 19. So our Vx2, it is 21 by 19 volt, right? Now similarly for the third case, means for this case, now again first we need to determine this current, and this current we can determine as VA minus 4, VA minus 4 upon 3 plus 1. So our current, it will be VA minus 4 upon 3 plus 1. So VA is 20 by 19 minus 4 upon 4. So it is 20 minus it is 3876 upon 4 into 19. So it is minus 56 upon 19 into 4 and this cancel. So it is minus sorry, not 16, 14 upon 19, right, ampere. Now I is this. Now again over here, plus is over here, minus is over here, and this polarity, it is in opposite direction to this. It means Vx1 will be equals to minus I into 1, right? So Vx1 minus I into 1. So it is minus 14 upon 19. So Vx1, it is equals to 14 by 19 volt, right? So we get the 3 voltage. Vx1 is 14 by 19. Vx2, it is 21 by 19. And Vx3, it is 10 minus 10 by 19, right? Now substituting this values in this equation. So what we are going to get? We are going to get like Vx1 is 14 by 19. Vx2 is 21 by 19, and Vx3 it is minus 10 by 19, right? So solving this one, we get 14 plus 21 minus 10 upon 19. So it is 25 by 19 volt, right? So this is our Vx. So our Vx, it is 25 by 19. So this is the answer to the first part of the question, which says that to determine the voltage level Vx in the circuit, right? So this is how we can determine the Vx using the superposition theorem. Now the next part of the question says, which is very interesting part, that to what value should the 2 ampere source be changed to reduce Vx by 10%. Now what it means? It means that we just in this circuit, we just need to change the value of this 2 ampere, right? And how much we need to change, that we need to determine, right? And what is the purpose of changing this 2 ampere? The purpose is to keep this Vx equal to 90% of what we get, right? Means we get the answer of Vx is 25 by 19. So as it says that we need to change the value of this 2 ampere source so that Vx be changed to reduce Vx by 10%. We need to reduce Vx by 10%. Means our new value of Vx, it will be 90% V dash x, means new value of Vx. It should be 90% of Vx, right? So 90% of Vx means this. Means our voltage Vx, it should be 45 by 19, right? And how we are going to obtain it? Just by changing the value of 2 ampere. It means that this 4 volt remains same, this 4 volt also remains same, right? And if they remain same, it means the component of Vx due to this voltage, it remains same. Yani it means that this value of Vx, it remains same, right? Since this constant is also same, so this also remains same. Only difference is this part, it is not going to be the same. This we need to determine. So if we got, since we want to be 90% of Vx, so it means that we know what we want. We know Vx1 due to first 4 volt battery, we know this Vx3 due to this battery, and now we can determine what should be our Vx2 that we want. So it means that if Vx that we want is 45 by 19, so it means Vx dash is equals to Vx1 plus Vx2 plus Vx3, right? Now Vx1 that we want, it is 45 by 19. Vx1 that is due to the first 4 volt, it is 14 by 19 plus Vx2, it is due to 2 ampere source, but this we need to find out again because 2 ampere battery we need to change, and plus Vx3, it is minus 10 by 19. So only one unknown is there, this. So this we can determine by solving this equation. So our Vx2, after solving this Vx2, you will get Vx2 as 37 by 38 volt. So this is the voltage. This is the voltage due to 2 ampere source, due to current source. And now we need to determine the value of the current source. How we can determine that? To determine that, like it is 37 by 18. So now coming back to this circuit, over here, now in place of this 2 ampere, it is this we need to determine, this is we need to determine, this Vx2 it is 30, it is 45 by 38, it is 45 by 38, right? Since it is 40, Vx2 is 45 by 38, so it means we can determine this I, right? What will be this I? Because resistance is 1 ohm, because resistance, let me this little bit, yes, so because resistance is 1 ohm, Vx2 is 45 by 38, so we can determine the current flowing through 1 ohm resistance as V upon R, which is equals to 45 by 38 ampere, right? So this is our I. Now similarly we can determine this I2, let it be I2, right? The current flowing through this 3 ohm resistor, it will be VA I2, it will be VA upon 3. Now what is VA? What is VA? So to determine the VA, simply what we can do? We can determine, because we know I, right? We know I, right? So from this, I can also be determined as VA upon 1 plus 10 by 7, which is equals to 7 VA by 10. Already we determined it. Now I is this 45 by 38. So 45 by 38. So our VA, it is 45 into 10 upon 7 into 38, right? Volt. So this is our VA. Substituting this value of VA over here, we get 45 into 450 upon 7 into 38 into 3. This is our I2, right? Now you can see, coming back to the circuit, we know this I2, we know this I. Now this IS, it is the current that is coming up, right? So applying the KCL at node A, what we are going to get? We are going to get that IS is equals to I plus I2, right? I is 45 by 38, right? And I2 is this. Taking this as common, we get 1 plus 10 upon 7 into 3, right? Now solving this 45, 38, and this is 21 plus 10 upon 21 equals to 45, 38 into 38 upon 21. This is this cancel out, so we get the answer as I guess I did some mistake. Let me check. IRV. So it is 45 by 38. Just a minute. 45. Right. Okay. Yes. So our Vx2 it is 37 by 8. So our Vx2 is not 45 by 90, it is 37. So it is like over here, it is not 45, it is 37. Since it is 37, so this will be 37. Similarly, this will be 370. And over here, this will be 370. For here also, it will be 370. This. So everything like 45, is just replaced with 37. So we get our IS as 37 by 21 ampere. So this should be the value of the current source to obtain Vx2 as this, right? So that the total this Vx, the value of this Vx, it is 90% of the Vx that we obtained using the 2 ampere current. So this is all about this question. If you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.